Hi everybody, welcome to trigonometry review. On that side you will see the list of the questions that we've done, and there will be the timestamp in the video description. Alright, let's start. The first question we have to find the complement and the supplement of an angle. So we have the complement and supplement of an angle. So complement or supplement of an angle, first of all, the angle must be positive. So I've just write the important thing here. So complement is where the sum of the angle equal to 90 degrees, and supplement is where the sum of the angle equal to 180 degrees, but the angle must be positive. That's just the way we define it. So that's what we have. Right. So for 113, the complement of 113 is, since the sum is 90, we will take 90 minus 113, and that is equal to a negative 27 degrees. Since the angle must be negative, so the complement, so that doesn't work. So there's no complementary angle. For supplement, we will subtract from 180. So that gives us 67 degrees, and that one's positive, so it's good. So we have the supplementary angle is equal to 67 degrees, and there's no complement. Next, I should update the list. Next, we will find the sum or the difference of the two angles given in degree minute, could be in second as well. So let's do it by hand first. So we have alpha equal to 92 degrees 20 minutes, beta 13 degrees 32 minutes. Right, we go from right to left. 20 minus 32, that's not enough, so we have to carry from 1 degree. So we borrow 1 degree, so that turns into 91, and we carry the 1 over, so 1 degree equal to 60 minutes. So we're going to add 60 to 20, that gives us 80. Then we'll just take 80 minus 32, that is 48 minutes, and then 91 minus 13, that is 78 degrees. Let's do this using the calculator. So first I enter 92. Second application, that gives us the degree. 20. Second application, minute. If we need second, it will be alpha plus, but we don't need it. in this problem. Subtract 13 degree 32 minutes, and we have that. But the answer, if we want to go to degree minute second, his second application, go to number 4, degree minute second, and that's what we have. Next, we have the coterminal angles. Coterminal angle is where the angle have the same initial and more important, the terminal side, therefore coterminal angles. So an example of that is where we just have an angle, we can go an extra revolution or 2, we just go around. As long as we stop at the same terminal ray, they are coterminal angles. So to find coterminal angles, all we do is just adding 360 or minus 360 or the multiple of 360 in general. So I just take 524 minus 360, which is 1 revolution, and we have 164, which is well between 0 and 360. So we did an angle that is also between 0 and 360 as well. So we subtract 360, 1 revolution, we have 164 degree. And in general, any coterminal angle will be just 160 plus a multiple of 360 degrees. So it could be positive, could be negative, integers times 360. So n is any integer. Sorry, I forgot to update that list. Right. So we have, in general, this is the form of the coterminal angle of 524 degrees. Next, we have in a triangle ABC, we have angle A, angle B, and angle C is equal to that. There's an important fact about the triangle. The sum of all the angles must be 180 degrees. So in general, for triangle ABC, A plus B plus C equal to 180 degrees. So we go to our problem. A is 34 degrees, B is x plus 61 degrees, and C is x plus 51 degrees, and that is, the sum is 180 degrees. Combine like terms, 34 plus 51 is 85 degrees. And 61 degrees as well. So we're going to combine like terms. I just have calculator here. So 34 plus 61 plus 51, so that's 146 degree. So if we add all the degree, that's what we get. And we have one x and there's another x, so that will be 2x. Equal to 180 degree. Subtract 146. So we have 34 degree. So x equal to 34 degree divided by 2. So that would be 17. So we have x. The question did not ask us for x. The question asks us the angle A, B, and C. Angle B is equal to x plus 61 degrees. So x is equal to 17 plus 61. So that would be 78 degrees. And angle C is x plus 51 degrees. So we have 17 degrees plus 51. That is 68 degrees. So we have B is 78 and C is 68. Alright. Next, we will not go over every problem. We might skip a few of this review. Right. So we have the 30, 60, and 90 degree triangle. It is a special right triangle. And for the 30 degree, 60 degree, and 90 degree triangle, the ratio for the sine of the length of the sine, or just the sine, is 30 degree is 1/2, 60 degree is square root 3/2, and 90 is 1. Meaning that in the right triangle of the 30, 60, and this is the right angle, opposite to 30 degrees is 1/2. The ratio, that is, opposite to 60 is square root 3/2, and opposite to the right angle is 1. In our example, the shortest side is corresponding to the 30 degree angles. It's going to be 8. So this is 8. We're going to need to find the other two sides. Alright, so this should be simple. We just take the ratio. For example, we take this ratio. Let's call this an x, and this is y. So cross multiply, we have 1/2 x equal to a times square root of 3/2, and multiply by 2 on both sides. Cancel this 2. We have x equal to a square root of 3, which is one of them. And then we'll take another ratio. Let's use the first and the last. Cross multiply 1/2 times y equal to a times 1, which is 8. So 1/2 of y is 8. So y must be 16. So in this right triangle, the other two sides will be a square root 3 and 16. Number 6. A building casts a shadow of 15 meters long. At the same time, the shadow cast by a 34 centimeter tall is 59. So we pretty much we have two triangles, and that's similar. So for a building, We don't know how tall is it. The shadow is 15 meters. At the same time, we have a pole, which is relatively, that is 34 centimeters. Tall. The shadow is 59. So these two triangles we assume to be similar, because at the same time the angle of the sun should be the same. Therefore, they are proportional to each other. So let the height of the building be x. So we have the ratio of x over 34 is the same as 15 over 19. 15 over 59, sorry. Cross multiply, we have 59 times x equal 15 times 34. 15 times 34 is 510. Divide by 59. On both sides we have about 8.6. They want to the nearest tenth, so we stop at 8.6, and the unit should be meter. Right. Then you might ask, even though the unit, one of them is meter, the other one is centimeter, but that should not be a problem, because x, the unit is meter, 34 is centimeter, 15 meter, 59 centimeter. So meter over centimeter, meter over centimeter. So the unit, the ratio of the unit also works. So that should be okay there. So times 10, 15, 36. Right, so that was 6. Next, we'll need to find x, and this is what we have. So we're going to label what we have. So AB is 44. BD is 25. D and O is 75. So what we have is both of them have the right angle, and this angle is common. We should have this angle equal to this angle because they are corresponding angle. So we have two triangles that are similar. We say triangle A, B, and O is similar to triangle. We start with this A, B, and O, and then C, D, and O. Notice the corresponding is extremely important. We end up with O in both cases, and we start with a acute angle, and then right, and then back to O. So A, B, O, and then C, D, O. They are similar, so the ratio of the angles would be AB, which is 44 over, so we take the first two, AB, C over CD, which is X, equal to, we have to use some length that we know, triangle ABO. So we're going to use B and O, which is 25 plus 75. that is BO over DO is 75. So we have this ratio to work with. 44 over X equal to 100. 75. And then we just solve for X. I'm not going to do that. That should be simple. Alright. Next, the terminal side of theta is in the standard position. So we have the point that's corresponding to the angle in standard position. So in our problem, we have X equal to 5. And then Y equal to negative 12. And then we need to find R. R is equal to square root of X squared plus Y squared. So in our problem we have R equal to square root of 5 squared plus negative 12 squared. That will be, if we put that in the calculator, or if we calculate, we have square root of 169, which is 13. Right. So we have X, Y, and R. The rest should be simple. We need to know the 6 trigonometric function. Psi is equal to Y over R. And I will let you finish the problem. In this case, it will be negative 12 over 13. Cosine is X over R. Tangent is Y over X. So we have those functions. And then the reciprocal of sine is cosecant will be R over Y. Whatever that is. Reciprocal of cosine is secant will be R over X. And reciprocal of tangent is cotangent, which is X over Y. Again, I will let you fill in the numbers. That should be easy. Right. Next, find the exact values of cosine of 60 degree and tangent of 60 degree. Right. For this one, we use the hand trick of 5, the values. Right. Cosine of 60 degree. Right. So I'll draw the little. So we have a hand here. 60 degree. We go from counterclockwise 60 degrees. So we're gonna cover that angle. So it will be like this. Cosine is on the left, so that's 1. Cosine on the right is 3. So in that case, cosine is on the left, so cosine of 60 degree. There's one finger on the left, so we have square root of 1 over 2, or just 1/2. And tangent. Tangent will be square root of the fingers on the right over the square root of the finger on the left. So it will be square root of 3 over square root of 1, or just square root of 3. So put it back in here. Cosine of 60 degrees 1/2. And tangent of 60 degrees is square root of 3. The common denominator, I will multiply 2 on the top and 2 at the bottom. So we have 1 plus 2 square root of 3 on the top, and then 2 at the bottom. So that is 9. I will do just either 10 or 11. So in this case, of course, there's a mnemonic to memorize this, like all star tech cache or all student tech calculus, something like that. But let's just base everything on the definition here. Right. First, the few things. We have x and y can be positive or negative, but r have to be positive only. Right. I think I'm do number 10 now. I'll let you do 11. Alright. Number 10. Tangent is positive. So first we start from the definition. Tangent is positive. Right. Tangent is y over x, and y again can take positive or negative, so I'm going to say could be positive, could be negative, divided by x, also positive or negative. Right, we'll worry about that later. Next, we have sine is less than 0. Sine is y over r. Y could be positive, could be negative, but r have to be positive. Right, so those are what we have. Now we will do the reasoning. Since sine is equal to negative, so this ratio is negative, and the only thing it have to be it is negative is where the top must be negative. So we're going to have this ratio when y is negative and r is always positive. That will produce the sine equal to something negative. Alright, so we have y is negative. So y have to be negative here. Next, tangent is greater than 0. So that means the ratio have to be the same sign. So either negative divided by negative or positive divided by negative. So x have to be negative as well. In that case, negative divided by negative is going to be positive. So we have y is negative and x is negative. So that must be in quadrant 3. That's one way to do it. There's a lot of way to do it. Or we can also do this. Right. First, tangent is positive is where tangent y over x is positive if it is in the quadrant 1 and 3. So the first quadrant everything is positive. So that's one's good. And tangent is positive in this quadrant as well. Because in this quadrant x and y both negative, y over x will be this positive. So we have 1 or 3. Next, sine is negative. Sine is positive on the first own store tech cache. So the first two sine is going to be positive. So only negative when it is under the quadrant 3 and 4. So sine is negative will be in this two quadrant, and overlapping is here. So that's why it is in quadrant 3. Right, I'll let you do 11. Right, Also, we will not do all of this. Just do a few, just to get the idea. By the way, this is important, so I think we do both 12 and 13. Right. So, find the exact values of the remaining trigonometric function. Right. So there is there's a lot of space. We need a lot of space, so try to write small. First, we start with sine is equal to negative 7 over 25. So we write sine is equal to negative 7 over 25. Sine is y over r. We have to know those ratios. Right. Next, since r have to be positive, so we can say r is equal to 25. So we say let r equal to 25. And then because of that, y must be negative 7. Right. So we have r and y, we just need to find x. Once we have x, y, and r, the trigonometric values should be easy. So we will use Pythagorean identity, x squared plus y squared equal to r squared. So we have x squared we don't know, y we know is negative 7, and r we know is 25. So do this, we have x squared equal to 25 squared minus negative 7 squared, and do that we should have 25 squared minus 7 squared, which is 49, so 576, and square root of that is 24. Right, one thing we need to pay attention to is x squared equal to 576. If we take the square root on both sides, there should be a plus or minus. So that would be plus or minus 24. Right. Next, it is in the quadrant 3. So in this quadrant, x is negative and y is negative. So x is equal to negative 24. Once we have x, y, and r, we know the rest. I'm just going to write the first field. Sine is equal to negative 27, negative 7 over 25, that's given. Y, and then we go to cosine, which is x over r, and then tangent y over x, and we just fill out this ratio, and then we have cosecant is reciprocal of sine, secant is reciprocal of cosine, and then cotangent is reciprocal of tangent. So just do that. That should be easy. Right, so that is 12. 13. Right. 13, first we have cotangent. Equal to negative 4 over 3. And the ratio for cotangent is x over y. Right. Now, in this case, we don't know if x is negative or x is positive. Actually, we do, but in the ratio by itself, x could be positive or negative, y could be positive or negative. So we don't know that. So we cannot just say x is negative 4, y is 3. Right. We need to consider it is in quadrant 4. So in quadrant 4, x is positive and y is negative. So since the ratio is negative 4/3, we have to let x be something positive. So we choose x to be 4, and then the negative will go with y. And then x squared plus y squared equal to r squared. So r equal to square root of x squared plus y squared. So square root of 4 squared plus negative 3 squared. So that will be 5. We have x, we have y, and we have r. The rest we just find the 6 trigonometric function, and that should be easy. Next, the reference angle. Reference angle, we'll do both of this at the same time. Reference angle is the angle made with the terminal x, the terminal ray, and the x-axis could be positive, could be negative. It doesn't matter. Whatever produce the acute angle. So 101 degree. It is in quadrant 2. So we have here is 101 degree. A reference angle is whatever it makes using the terminal ray, this terminal ray, with either positive or negative x-axis. We're going to choose the negative x-axis because this angle is an acute angle. So the upper half of the revolution is 180. So we're going to take 180 minus 101 will give us this angle in here. So 180 minus 101 will be 79 degrees. Right. So just use the definition to find the reference angle here. Uh, 240. So we start with 0, that 90, 180, and 240. So somewhere in the third quadrant. So we will take the terminal ray, this, and with either positive or negative x-axis, whatever produces, whatever gives us an acute angle. So we're going to use that acute angle. Since we go 240 and take away 180 from the top, and that's all we have. So we're going to take 240 minus 180, and that is 60 degrees. We have 14 and 15. Times 10. Right. Next, we find the exact values of this trig function values. We're not going to find everything. I'll just do one of them. So first, when we have an angle that is more than outside of 0 and 360, we can always use coterminal angle. So we subtract 360 to bring it down to an angle that is between 0 and 360 degrees. So if we subtract 360 degrees, we have 330 degrees. That is coterminal angles. The value should be the same. Right. Next, we need to determine two things, the reference angle and then the size. So the reference angle, we use this notation. So it is 330 degrees, 0, 90, 180, 270, and 330. So that is 330 degrees. 330 degrees. And the reference angle is going to be this one. So we take 360 minus 360 is the whole revolution. Take away 330. So that is 30 degrees. So reference angle is 30 degrees. And next we just need to determine if tangent is positive or negative. Since this is in this quadrant, x is negative, x is positive, y is negative, and tangent is y over x. So tangent is going to be y over x. Negative divided by positive is negative. So tangent of 360 degrees is equal to a negative of the reference angle. Right. So we find the reference angle and we go from that angle to reference angle. Still need to determine if it is either positive or negative. In this case, it is negative. So that will be negative of tangent of 30 degrees. And 30 degrees using the hand, so it will be that the number of fingers on the right over the left. So square root of 1 over square root of 3. So negative 1 over square root of 3. Right. And the others will be similar. Next, find the possible values of theta so that cosine is equal to 1/2. So we know cosine is equal to 1/2. Cosine is x over r. Or if we use the right hand, the hand trick, cosine, remember, is the finger on the left. So we only have one finger on the left, so that will be 60 degrees. So we'll be right at 60 degrees. This one give us cosine is equal to 1/2. And also there's a point here, because those 2 points will have the same x values and r is still the same. So either it's going to be 60 degrees or it will go all the way to here. So if this is 60, that is also 60. So 360 minus 60, so that either we're going to say it is negative 60 degrees, or the answer must be from 0 to 360. So coterminal of that, we add 360 to negative 60 or 300 degree. Again, we can use negative 60 degree, or we use the coterminal angle. We add 360 to it and make it 300. Forgot to put 18. Right. Next, we have this rather simple. Sine is equal to negative 1/3. Cosecant is 1 over sine, so that's just reciprocal. So we just flip this, negative 1/3, so negative 3 over 1, or just negative 3. Right. Next, we have the quotient identity to find cosine. So we have cosine, sine, and cotangent and cosine. The ratio that relates all of them is cotangent is equal to cosine over sine. So if we have to solve for cosine, we're going to multiply or cross multiply in here. So give us cosine equal to cotangent times sine. Cotangent is 5 over square root of 11, and sine is square root of 11 over 6. Multiply them, give us 5 over 6. So this is pretty simple. Right. Number 22. Actually, 22 is similar to 12 and 13. Right. I'll get started. So we start with tangent equal to negative square root of 13 over 6. And tangent is equal y over x. I should not put the negative top or the bottom. We don't know that yet. Right. We do know though, secant is negative and secant is 1 over cosine or reciprocal cosine. So secant here is reciprocal cosine, where cosines are over y over, cosines x over r. So secant is r over x is negative. And r is always positive. The only thing can happen is x must be negative. So we have positive r divided by negative for x. Positive divided by negative is negative. So from here we have x must be negative. So with that, the negative here have to go with x. So we say y is equal to square root of 13 and x is equal to negative 6. And then r, square root of x squared plus y squared x squared plus y squared. So 36 plus 13 49, so that would be just 7. So R is 7. We have x is negative 6, y is square root of 13, and R is 7. The rest is easy. We just write out the ratio. Sine is equal to y over R, and you know the rest. Right, so this problem, again, we write out the ratio. We don't know which one is negative, which one is positive. So we go to the second condition, and secant is equal to R over X, and it's negative. R cannot be negative, but X can. So we'll choose X to be negative, and we deduce the rest. X must be negative, and we can find the rest of the problem. Right, so that is 22. Right. Next we have some basics identities. So this we just either do algebraic manipulation or use some trick, basic trick identities. Alright, so from here we just have to multiply it out. 1 times 1 is 1. 1 times cosine, negative cosine times 1, negative cosine times cosine is cosine square. Right, so that's easy. This cancel out, this cancel out, and that's just 1. Right. That was 23. Right. Next, verify. So we don't know if it is true or not. So I will start with the left hand side. An easier way to do this is just convert everything to sine, cosine. So tangent square, we can write sine square over cosine square, and 1 minus sine square. So 1 times 1 is 1. 1 times negative sine. So, and then sine square times 1. So we still have sine square over cosine square. Right. And then multiply that. Right. Can we simplify this? Doesn't seem. It can, but it's not obvious. So let's try something else. So that doesn't work this way. Right. Try something else. We're still going to use 1 plus sine square over cosine square. But what we need to is take a look at this. 1 minus sine square. So since we have sine square plus cosine square is 1. So if we subtract sine square on both sides, we have cosine square equal to 1 minus sine square. Right, so instead of 1 minus sine square, we use cosine square. So let's try again. That doesn't work. We still have 1 plus sine square over cosine square and then 1 minus sine square, we're going to use cosine square x. Now we multiply it out. 1 times cosine square is cosine square sine square cosine square times cosine square. Okay, so here, and we have cosine square plus sine square equal to 1, which is good. So this one is true. It's 24 times 10. Right, 25. Right, cosecant is, again, we look at the left hand side. Cosecant is 1 over sine. So cosecant square 1 over sine square. Cosine is cosine. Secant is 1 over cosine. Right. So the first step there is the simplification there. Next, that gives us 1 over sine square minus 1. We can combine these two used in the common denominator of sine square. So the bottom we have sine square. The top is 1 minus sine square. Right. 1 minus sine square, we did see that earlier. This is cosine square. So we have cosine square over sine square. We can write cosine over sine, and the square is on the outside. Cosine over sine is tangent, cotangent. This is also true. Right. 26 and 27. This time we use the trick based on the opposite, hypotenuse, and adjacent, not x, y, and r. So with respect to this angle theta here, sine is equal to opposite over hypotenuse. Opposite over hypotenuse. So just that. Right. For triangle ABC, now we have to draw the triangle with angle at right angle at C. So let's choose A and B. Let's say A, there's B here. Opposite to angle A is the sine A, and the sine A is 4. opposite to angle B is the sine B, which is square root of 65. And the question asks for sine A. So sine of A is equal to opposite over hypotenuse. I'll just find the hypotenuse and then put it in here. So that should be easy. So I'll let you do it. Right. Next, we're trying to find the theta that satisfies this condition. So this we have the sine to cosine. So that is the cofunction relation. The function and cofunction. That's a theorem. I should write that theorem. So in general, it could be any function. So we say a trig function values of an angle is equal to the cofunction of the reference angle. So remember, sine, cosine, that's why they are called the cofunction. I'm sorry, I don't know why I put the reference angle there, which is not the case, which is, I should put complementary angle. Sorry. So meaning that they have to add up to (90°). So in this case, the complementary here define a little loose because some of them could be negative. As long as they add up to 90°, I should say. So sum is equal to 90°. An angle could be negative. Back to the math here. 4 theta plus theta, so that's 5 theta minus 30 equal to 90°. Add 30 on both sides. 5 theta equal to 120 degrees. Divide by 5 is 24 degrees. So that's what we have for 28. I should move the board here. Right. Next, solving right triangle. Solving right triangle involves that we will have to find all the sides and all the angles. So in this triangle, A is opposite to A, B is opposite to B, so this is going to be angle B is equal to 66 degrees. That is given. Angle A we don't know, so we need to find angle A. And then the sine B we don't know, and the sine A we don't know. Right, first, A plus B plus C is 90 degrees. By the way, we assume that this is going to be C. First, A plus B plus C is 180 degrees. So when we are given two angles, we know the rest, the remaining angle. So A plus B 66 let's see 90. So A, we just take 180 minus 66 minus 90. 180 minus 66 minus 90. I don't need to calculate for that. So A, 24 degrees. So this is exact. And now we just need to find A and B. Right. We have to use some trigonometry here. So we can just use either, pretty much anything. So let's say we're going to use 19 degrees for sure. 19 degrees is the hypotenuse. So let's say we use 24 degrees or 66 degrees, doesn't matter. With respect to angle A, we have opposite and hypotenuse, so that's going to be sine of angle A is equal to opposite over hypotenuse. Particularly, angle A is 24 degrees. So sine of 24 degrees equal to opposite, which we don't know, over hypotenuse, which we know is 19. Make a fraction, cross multiply, so we can say A equal to 19 times sine of 24 degrees. Right. Make sure that it is in the degree mode when we use the calculator. So let's turn on the calculator mode. It has to be in the degree mode. So go to degree. So that's good. Now we have 19 sine of 24 degrees. And that is 7.7. And just use one decimal place. Right. And next we can use Pythagorean theorem to find B. Sorry, I shouldn't put the calculator there. Right. We can use the Pythagorean theorem, or we can also use another trick. And I will do using the trick here. So with respect to angle B, so this is adjacent. So with respect to angle A here, how about adjacent over hypotenuse, which should be cosine. So we have cosine of 24 degrees equal to adjacent, which is B, and over hypotenuse 19. Once again, write a fraction, cross multiply, B equal to 19 cosine of 24 degrees. So 19, we'll need to show the calculator here. So I got 17.357. So let's say 17.4. Right. The reason the key only have 17 because all of the numbers only have two significant figures. So we should only have two. So 17 is perfectly fine. Right. Now, why didn't we use the Pythagorean theorem here to find B? Actually, we can. The only thing that the reason that we didn't use it because the way we calculate here, notice that angle B is given, therefore that is exactly 66 degrees. Angle A, when we subtract, that is also exactly 24 degrees. The angle, the sine A here, that is approximately, so this is not exact. So since this is not an exact values, we do not want to use the calculation based on anything that is not exact, because the error might be magnified. So instead of using 19 and 7.7 to find B using Pythagorean theorem, I don't want to use 7.7 because that's not given, that is not exact. So that's why I will go with the cosine equal to adjacent over hypotenuse. 24 degree is exactly 24 degree. 19 is exactly 19 because that's what given. And so the calculation will be better. Right, so that was 29 timestamp. Right, 30. This one obvious, we have those two sides, we can find C easily. Pythagorean theorem, I'll let you do that part. We still need to find just angle A and angle B. So angle A or angle B, I'll just pick one there. I use A. With respect to angle A, what do we have? With respect to angle A, we have opposite is that, and adjacent is this. So we just say opposite over adjacent. That is tangent. So we say tangent of A, we don't know, degrees is equal to 28.34 over 17.92. So if that is tangent, we take the tangent inverse, we should find an angle A. So calculator, again, that should be still in degree mode. So this, which is good. Second tangent, and we have 28.34 divide 17.92. And I got 57.69 degrees. They have 4 significant figures, so let's just use 4. 57.69 degree. Right, so we have A, and we have the angle C, which is 90 degree. Subtract those from 180, we should have angle B. So that also work. So 180 minus 90 minus 57.69, we get angle B. So that's easy. And then the sine C, we use Pythagorean theorem because we know A and B. I mean A and B. Right. However, just like the last problem, we don't want to use the 57.69. This is the derived values. It's approximation. We're going to use those exact values, the given values. So for angle B, with respect to angle B, let's just say it's going to be different now. With respect to angle B, this is actually going to be opposite to angle B and adjacent to angle B. So let's use opposite over adjacent, and that also tangent. So tangent of B is equal to opposite over adjacent. So B is equal to tangent inverse of 17.92 over 28.34. I'll let you finish this one. But we do it this way, we use whatever given. We will be better than the approximation we have along the way. Right. So that is 30. Nice. Now we have a little application here. Find the height of the pine tree that casts a 40-foot shadow on the ground. Assume the angle of elevation from the point on the ground to the tip of the shadow to the sun is 64 degrees. So let's see. We have assume the flat. The ground is perfectly horizontal. And then the pine tree. Let's say it's pine tree. So that it will cast a shadow. So let's say go like this. The sun is way up there. So here's the sun. Cast a shadow, and the shadow is 47 foot. So 47 feet there. We assume the pine tree grow perfectly vertical, and the angle of elevation from the point on the ground at the tip of the shadow. So we go from this point, and the angle of elevation is 64 degrees. I didn't draw very well, but at least that's what we have. So this is a right triangle. So we have a right triangle here. The pine tree. And that. So let's see what we are given. 64 degrees. And what we are asked to find the height of the pine tree. So we don't know this. Let that be x. So in the right triangle here, with respect to 64 degrees, we have x as opposite and 47 as adjacent with respect to angle 64 degrees. So what ratio has opposite and adjacent? So let's use opposite over adjacent, which of course is tangent. So we have tangent of 64 degrees. Opposite, we don't know what it is, but adjacent we do know is 47. Again, cross multiply, we have x equal to 47 times tangent of 64 degrees. Let's use calculator. Is that still in degree mode? Okay. 47 tangent of 64, 96.36. The reason we only take two, they want to the nearest foot, so that's out of the question. So that's 96 feet long, 96 feet times 10. And that was 31. Right. So sorry, that was 32. Right. And go back to 31. A tree is supported by a rope anchored in the ground and attached to the tree 13 feet above the ground. If the ground is flat and the rope is 31 degrees with the ground, find the length of the rope to the nearest length. So again, let's assume the ground is perfectly horizontal. and then there's a tree. Let's see, like that. And we will attach a rope anchor in the ground and 13 feet above the ground to the tree. So we're going to pick the point on the tree that is 13 feet above the ground, and we'll attach a rope to it, which make 31 degree angle to it. The question is, find the length of the rope. So it has to find this length. Alright, so to find that, we have 31 degree is the only angle we have. So we have 31 degree. Alright, now with respect to 31 degree, this is opposite and x is hypotenuse. So if we use opposite over hypotenuse, that is going to be sine. So we have sine of 31 degree equal to opposite over hypotenuse. Cross multiply x times sine of 31 degree equal to 13. So I will divide by sine of 31 degree. Calculator. 13 divided by sine of 31 degrees. Have about 25.24. And again, this is to the nearest foot. Yeah, to the nearest foot. So about 25 feet is the height of the tree. Right, 33 and 34. 33. The bearing point A and point B. So the bearing, I think we assume with respect to this angle. So with respect to this point, to go to A, it is on the north side and 12 degree east. So point A is with respect to north, we're going to 12 degree on the east side. So the bearing we're going to write with respect to the north-south line, and then whatever the angle we go from the east or the west. East is on the right, west is on the left. Point B is here. So this is with respect to north, and we go some angle in the east side. Just need to determine the angle. So we go from north here. So since that is 90 degree angle, take away 20, so that should be 70 degree. So that's what we have. And then go to 34. So this is navigation here. So first, the hiker will walk north 19 degree 0.7 is an hour and a half at 4 miles per hour. So first, you walk in this direction. The angle here north on the east side of 19.7 degree. Next, we need to find the distance though. 1 hour and a half at 4 miles per hour. So the distance is equal to speed times time. So 4 miles per hour, an hour and a half. So that would be 6 miles. So we take 1.5 hour times 4 miles per hour equals 6 miles. So the distance that the hiker goes is 6 miles in that direction. After that, the hiker walk at the bearing 70.3 degree is south. So from that point, now it's going to be south 70.3 degree east. So this angle here is south 70.3 degree on the east side. And walk like that for 2 more hours at 6 miles per hour. So 2 more hours, 6 miles per hour, 2 hours times 6 miles per hour. So that gives us 12 miles in total. And the question asks us, what will be, how far is he from the starting point? So we're going to find this distance. Here, let that distance be x. Right. So first of all, if this angle is 19.7, this angle should be also 19.7 because there are two parallel lines and those are interior, alternate interior angle. So those also 19.7. This is 19.7 degree as well. So 19.7, let's use the calculator real quick. 19.7 plus 70.3, it is 90 degree. So we have a 90 degree angle here, which is nice because if it is like that, then x is the hypotenuse and we have the two legs. So x squared equal to 6 squared plus 12 squared. That should be easy. 12 squared plus 6 squared is 180. So x equal to square root of 1. I don't know how I write the degree there, which is let's ignore the unit here. That should be miles square. But anyway, square root of 180. I got 113.42. And it's set to the nearest 10 of a mile. So the key here is we have to draw the diagram good enough so we can see actually where it is. And it just happened to be a right angle. And with that, we finish this review. I hope you found this helpful. Thank you for watching.